It's been a little over 7 months since we've covered a full printer build on this channel, and if you ask me, that's way too long. One of my goals has been to highlight some of the live build series we do on the Modbot Army channel in a more condensed, easier to digest format. But the reality is these projects take a long time, so we usually only get to tackle a few per year. One project I've had my eyes on for a long time is hartk's Micron, a printer that takes the adorable form factor of the V0 and combines it with the absolutely awesome flying gantry of the Voron 2.4. I came really close to building a Micron on multiple occasions, but given that the original one has the exact same form factor as my V0s, I was never able to really justify it. But with the release of R1 and the Micron Plus, the version that takes the 120 build volume and expands it to a 180mm cube, I knew it was finally time to take the plunge. Now that the build has been done for around 3 months, I am really excited to show off this epic printer. In this video, we'll dive into the Micron Plus, go over the printer specs, talk about the assembly process, and I'll share my overall thoughts based on my time with it so far. So with all that being said, and without further ado, let's get right into today's video. Before diving in, I did want to take a moment to thank LDO for providing the Micron Plus kit used for this channel. If you're interested in finding out more or picking up one of these yourself after watching the video, I will have links in the description. Now for a little history on this printer. The original Micron has been around for several years, and it's built up a pretty loyal following. It was designed as a compact machine that captured much of what people loved about the flying gantry design, but in a smaller form factor. I've followed hartk on X for years, and always get excited anytime I see him posting something new that he's working on for Micron. Many of those updates eventually came together as R1, an official revision that introduced a host of improvements and refinements over the original design. R1 is available both in the original 120mm design as well as the Micron Plus, with the key differences being different sized extrusions, different sized rails, as well as obviously different sized panels. The entire Micron project is open source under the GPL 3.0 license, and in the GitHub repo you'll find all STLs, step files, DXF files, firmware specific things, and an entire bill of materials if you decide you want to self-source your own. If you don't want to self-source, there are also various partial and full kits available for whichever direction you decide you want to go. For my build, we used the LDO Micron R1 Kit. With this particular kit, your options for extrusions are black or space gray, and I've almost always gone with black extrusions for my builds, so I opted to finally check out the space gray, and after having them in front of me, I've got to say they are absolutely gorgeous. The LDO kit comes with just about everything you'll need for this build, with the exceptions being the printed parts as well as a hot end. With that out of the way, let's take a closer look at hardware. For some of the choices or some of the components on Micron, there's a few different assembly options or parts you can use, and I will do my best to point out some of those. Also, just keep in mind that my printer is based off of the LDO Micron R1 kit, so a lot of the specs will be specific to that kit, and yours might be different unless you get the kit or decide to source the exact same parts. Today's video is brought to you by PCBWay. With over a decade of experience, PCBWay offers high-quality PCB prototyping and fabrication solutions. Along with PCBs, they also provide CNC machining, 3D printing, sheet metal fabrication, and injection molding services. I've used PCBWay for a range of projects over the years, including small batches of PCBs, plus CNC and SLM parts for custom printer builds. I've always been really impressed with their quality and super fast turnaround times. If you're working on your own project but need some help bringing it to life, check out the link in the description below to see everything PCBWay has to offer, and to get $5 off your first order today. The frame is entirely made of 1515 extrusions, the same exact size that's used on the V0. If you've never handled them before, let me tell you that they are adorable, but there is a catch. Since the channels are so small, you can't just easily drop in an M3 nut, so you need to pay special attention to that during the assembly process. In the LDO builds specifically, they do have these sort of specialty produced nuts that are smaller than standard M3 that you can drop in. However, they are still a lot trickier to get aligned, so they're really nice to have if you want to upgrade the printer later or just forgot one or two, but you're going to be much better off preloading as many of those nuts as possible. For motion, X, Y, and Z all use linear rails. Z and Y are fitted with 7mm rails, and the toolhead rides back and forth on a slightly larger 9mm rail. This printer uses Core XY kinematics, and 4 independently driven Z motors to raise and lower the entire gantry, giving it that flying gantry that most know from the Voron 2.4. The idlers and the bearing stacks are one area where you have a few different options. For this, you can use the more common bolt that passes through the bearings, but there is an alternative for precision pins, which is what the LDO kit uses. Moving on to the toolhead, while there are a few different options, the standard is Anthead. This is a highly customizable toolhead that lets you configure the printed parts to work with a variety of different extruders, hot ends, and probe options. The LDO kit includes the Galileo 2 or G2 extruder, as well as Clicky for the probing setup. Since the hot end isn't included with the printer, I opted to use one of the Next G hot ends that I had laying around with the ultra high flow attachment to it. For cooling inside the toolhead, Anthead uses two 4010 blower fans for all of your layer cooling, as well as a smaller 2510 for cooling your hot ends heatsink. The LDO kit came with parts for leaf cutter, an optional upgrade for the Anthead toolhead that gives it a filament cutting arm, which is intended to be used with an automatic filament swapper. However, during the time I was building the toolhead, hartk mentioned he really liked the Fysetc Crossbow, which is a small CNC mod that uses a blade and two magnets to cut the filament. So that is the one thing I decided to order and upgrade instead of leaf cutter during the assembly process. The 185mm bed is pretty beefy at 8mm thick, and after running quad gantry leveling as well as a bed mesh, I'm getting a bed deviation of approximately 0.06 give or take, which has led to extremely consistent first layers. Now let's look at electronics. This is one segment where if you self-source, it will be vastly different, so I will just cover what comes with the kit. All of the electronics are mounted on the underside of the printer using two DIN rails for attachment. The main board is the LDO Leviathan, which uses onboard TMC 2209s for all of the Z motors and then 5160s for the AB motors. This is using a Raspberry Pi 4B that's connected to Leviathan via UART. The bed is AC powered, so there is an SSR for controlling that, and this shipped with LDO's new compact LCP324 power supply. This is a 300 watt unit, and outside of its form factor, making it perfect for a build like this, it also outputs both 24 volts and 5 volts. In my case, since the Pi is connected via UART, the Leviathan is actually powering the Raspberry Pi, but having access to 5 volts like that is going to be handy for a lot of custom builds. The toolhead is using LDO's Nighthawk 36, which uses USB connection. So there's only one single cable coming from the toolhead back down to the bottom of the electronics bay. This really helps to keep the entire toolhead clean, makes swapping things out a lot easier, and has the added benefit of having an onboard ADXL for running input shaping. Up front is a 4.3-inch touchscreen running Clipper screen that is a really nice upgrade over my V0s that either use kind of a small rotary screen, or I think one of them is even running headless. The touchscreen with Clipper screen is probably my favorite setup or interface out there. Now that we have a pretty good overview of the specs, let's talk about what the actual build process is like. This all starts with printing out the needed parts, which need to be done in ABS or ASA, and the printing parameters are the exact same as what you would need for building a Voron. Since this printer has a ton of different options for parts you can use, there is an online configurator that you can find linked in the GitHub repository. Here you'll enter in the specifics for your build and the parts you're going to be using, and it spits out all of the needed STL files. Even having the LDO bomb, there were a few things in that configurator that weren't entirely clear to me, so I ended up reaching out to hartk before starting the build just to get some clarification. I did make the recommendation to add an option for the LDO kit where it either said that or you can just click a button and it gave you all the things for this specific kit, but as of recording this, it doesn't seem like that's been implemented into the configurator. For anyone that is building this printer using the LDO kit, there is also a separate folder inside of the GitHub repository containing extra STLs you'll need to print for some of the various mods that this printer uses, like LED holders, the LED light bar attachment, and just a few other pieces, so make sure you print those out. For filament, I used LDO's light blue ABS for all of the primary colors and LDO orange ASA for all of the accent pieces. I can't take any credit for this color combination. As I was sort of kicking the can on what colors I wanted to go with, hartk ended up sending over a couple renders. I think it was like 3 different options. And when I saw the orange and blue, I knew that's what I was going to go with. During my build, the manual covered quite a bit of the sub-assemblies pretty well, but once I was relying exclusively on CAD, there was a fair bit of head scratching, especially for the pieces that came in multiple versions where it wasn't immediately clear what version I had with the LDO kit. The good news is that as I was putting together this video, I checked and saw they have made a ton of progress with the official manual. It is marked still as work in progress, but they updated it as recent as last week, so things are definitely heading in the right direction. I love having the CAD and think it's excellent as a reference, but if you're someone that hasn't really played around with any CAD software, it is not nearly as smooth of an experience as just having a PDF manual. Since Micron can be used with various toolheads, the Anthead assembly process is not a part of the primary manual. The good news is that if you head over to the Anthub repository, there is a PDF file that will guide you through just about everything, with the exception being the clicky specific installation. The things that took me the longest with this build were the Core XY motion system as well as the toolhead. For the motion system, a lot of that was just me trying to figure out via CAD what parts I had and what parts I should be following to actually get these pieces assembled. For the toolhead, this was my first experience ever with Anthead, and part of the time-consuming aspect of it was just trying to figure out how to best route everything around the toolhead as I was assembling it. Also for clicky, since I used an ultra high flow hot end, I had to get a little bit creative with the probing block. For this, I ended up soldering some wires to the limit switch probe to extend them, which worked fine. And depending on which hot end you're going with, if it's a standard size or even a medium flow, this will be a non-issue. While I do think that this build was more challenging than the Voron printers I've assembled, seeing the work that's been made with the manual is really reassuring, and once it's complete, I think it's really going to enhance the overall build experience and improve the project's overall accessibility. Since the build series, outside of working towards dialing in a couple of profiles and cleaning up a few macros, the printer's been solid, and it has quickly become one of my favorite printer builds or printers that I've built to date. It looks gorgeous, heats up really quickly thanks to its size and the AC bed, and the 180mm build volume covers just about anything that I regularly need to print. As for future plans, I'm still largely undecided. At one point, I swore I was going to be turning this into a 2-tooled tool changer, but I don't think I want to sacrifice any of that build volume. Right now, I'm leaning more towards a Night Owl filament switching setup, as well as a couple smaller quality of life mods like chamber fans, or maybe even an eddy current probe to replace clicky down the road. I'm really happy to finally have a Micron in the fleet, and I've decided that this is going to be replacing my Studio V0 for all of my small to medium sized prints. And that's been Micron, or specifically in this case, the Micron Plus. I hope that you enjoyed this video and that you have a better idea of what it is, what the build process is like, and what to expect if you decide to pursue building one of these for yourself. If you have any questions, let me know in the comments down below and I will do my best to answer. On that note, don't forget to like and subscribe for more great videos. We make a video just about every other week, so there's always fresh content coming your way. If you want to support the channel further, I'll have links in the description over to our Patreon, where there are some really awesome rewards. Huge thank you to all of our existing Patreon supporters. I appreciate each and every one of you for allowing me to come back every single week and spend more time doing what I love, which is making content for you all to enjoy. On that note, this has been Daniel from ModBot. I look forward to seeing you guys in my next video. Peace. Peace, guys.